Yeah. All right. We're going started? All right. It's giving me the thumbs up. This is going to be really difficult for me because I really like to pace, and I can't pace because I have to stand right here where this microphone is. I'm sure my hands will start moving a lot more because of that, so bear with them. My name's Glenn. I'm a program manager on the .NET team, specifically on the ASP.NET Core team. Too much talking, apparently. So specifically on the ASP.NET Core team, I've been working on it since the very beginning, basically. There was a little bit of prototyping stuff done before I joined, but otherwise I've been there since the beginning of the thing that is today known as ASP.NET Core. Back then it had very different names. And more specifically, lately, in the last kind of, I don't know, a little while, a couple of years maybe, I have had a focus on what ASP.NET Core, or to give it a more general name, what more could .NET Core on the server do to help you guys building things like microservices, things like cloud native applications more generally, and microservices in specifically. So what we're going to talk about is we're going to talk about some stuff that we've got today. We're going to talk about Swagger, health checks, tooling, HTTP Client Factory. And we're going to talk about some stuff that we're going to have support for tomorrow and how you can build those things out today. We're going to talk about application models for message queues and how you might be able to build those today and use those today, leveraging everything we've got. Then I'll show you what's coming to make that better and easier and harder, faster, stronger, better. And then later we're going to talk about gRPC metrics. So this timeline is both the order that we're going to talk in it and probably the order that you'll see it come out from Microsoft. The further through the slide deck we get, the more tenuous and weird, and the last two slides are literally from a design meeting we had this morning. So you can take them as you will. So I got a mandate from my bosses. I have bosses like everybody else, and it went something like, make ASP.NET Core great for building cloud native apps, especially for microservices. And I said, what does that even mean? And they said, microservices, what do we even pay you for? Go work it out. Or something like that. And I said, okay, sure thing, yes sir, boss. So we started to talk about things like this. We're talking about this top list of stuff here: N-tier, Queue-worker, event-driven, CQRS, microservices. If you go to Azure Docs and you say, how do I build a cloud thing? They'll give you this list. And they'll say, these are the most common things we see people doing who are making the best out of utilizing Azure to gain the best of the stuff that they can. I'm like, oh, great. That's cool. ASP.NET Core, it kind of really only works best with that top one, N-tier. That's probably a problem, right? Like, in terms of like the core stuff that's in the box, right? It works best with that. It's kind of where it came from. It works okay with all the others. Everything that's in this list, you can build with .NET Core, right? We have the stuff all over the ecosystem, all over the community. We build stuff. Everybody's built stuff. But it was best for that first thing and kind of okay for everything else. Not something that our team had ever really focused on making first class. So the first thing was like, hey, let's look at all these things. That seems pretty obvious. People building cloud native are building this. If cloud native is important, let's make that better and more first class and more supported. And then there's a bunch of different principles and concerns that you end up seeing. If you're building cloud native apps, you're decentralized. Observability becomes a really big problem. When you've got 500 microservices running in a cluster and something's going wrong, it's a lot harder to see what that thing is and where that thing is than when you've got just one big application with a fairly consistent log stream coming out of it. Right? So metrics, diagnostics, logging, you start seeing things, especially in microservices, polyglot persistence and polyglot languages, like all different sorts of languages and different databases, all within the same application space. Gone is the day of one big SQL Server database or one big Oracle database with like a really big, with a big data tier and a big services tier and a big UI tier, right? That sort of stuff. You can make work here and you can port it to the cloud, but it's not what you do if you're designing for the cloud up front, which is kind of what we're talking about here, right? And then you see async communication, designing for failure. Suddenly, mean time to recovery became a really important metric that we didn't know about before, or that people didn't necessarily care about before, things like that. And mutable infrastructure. Now, APIs seem to be pretty common to all of these types of architectures and things. It seems that if you're going to build one of these types of things, you probably got a bunch of APIs. Probably. And so we said, okay, what does an API look like then in this ASP.NET Core world? And I started to look at that. We're going to look at it today, and we're going to show the today stuff. Like how did we just, to begin with, how did we just start making APIs better? Because in almost all these application types, you care about APIs, right? There's a few people nodding. They're like, yeah, I like me some APIs. That seems like a pretty good deal. Yeah. Okay, so I did a file new web application, and it's apparently deciding to spin. Project successfully created, but I'm still going to wait. I'm not really sure what it's doing, but apparently it's decides now's the time to do it. Oh, hey, it's okay. It's a good thing. We were waiting for you, Visual Studio. It's all right. Okay. All right, so this is pretty standard. Have you guys seen this before? Actually, first hands, has anybody just not done any ASP.NET Core? Okay, great. Some of this might have been really confusing if you hadn't done anything before, because I wasn't going to go over lots of basics. Okay, so let's talk about this. This is standard values controller. You do F5, you get an API, right? Cool. So the first thing I started to look at, if I'm building a microservice, say, well, this thing doesn't seem real useful. I don't think I'm going to have a www root anywhere anytime soon, because I don't really care about UI. Well, I kind of care about what's in this values controller, because that's where I'm going to write code. Kind of unfortunate that's in a subfolder. Let's fix that. So let's move this out. We don't care about lots of controllers because it's a microservice, right? I'm only going to do a small amount of stuff, so let's just delete that. We don't really need to manage that. It seems fine. What do we got in values controller? Let's see. Hello? Zoom out. Oh! Look, it's just going like this. Minuses instead of actually zooming out. This is a great set of demos. Good job. Good job, Windows. Bam. Look at that. And I better close that because I just realized it's open, and otherwise someone will start talking to me. Okay. So let's open up this and say, well, our values controller is kind of okay, but this API slash is kind of a holdover from when I was going to be mixing UI and API into my same app. So I'm not super concerned about keeping that around. What else? There's a lot of stuff here that isn't necessarily useful for my cloud native microservice. So let's continue on this journey of turning this application into something that's actually good for the foundation that we're looking for, right? Okay, let's jump into Program CS. What do we got? Okay, so Barry Dorans, if any of you watch Barry Dorans talk, he will tell you that everything that's in this bit is useless in a service. Not useless, but mostly useful if you're going to have UI and API in the same thing, which is kind of what you did a lot with Web API, not so much what you're doing in this world. HSTS is mostly useful for a browser, or only useful for a browser. And if you're going to do HTTPS and somebody your clients aren't humans, so if your client talks to your API and it sends it your auth token over HTTP, it's kind of already too late. So your API then redirecting to HTTPS probably doesn't provide the most value. So what we probably want to do is just do HTTPS and don't bind to HTTP for your APIs and force everybody to use it that way. So the redirection and stuff, let's remove that, make it a lot simpler, which is nice because if we're going to have a microservice, we're going to have lots of small amounts of code, seems good to be able to focus just on what we care about, right? Cool. So now that I've deleted a bunch of stuff and complained about everything that's been in the box for so long, let's talk about what we can add. What have we done to help out that makes this useful? First of all, does everybody like this? Do you think this would be better, file new for what you expect to get from microservices? It's a few nods. People are like, yeah, if I did file new and got that seems like it'd be okay. Cool. All right. So first thing, let's talk about health checks. If you're going to build an application that has lots of, let's risk zooming once more and hope it works this time so that you guys can see. I don't want anybody thinking man, I can't see anything this guy's doing. So we're going to go services that add health checks. Oh, look at that, it zoomed out. So happy. And then we're going to say app.use health checks. And we're going to say / this here, it takes a string. And optionally, it also takes a port number, which is interesting. So I could say here, I'm going to add this health check. It's going to be on /health, but only if you talk to my app on port 9000. And then I would tell Kestrel to listen on port 9000 as well. And that way you could do things like play firewall blocking, so it can only be accessed from internal or something like that, rather than trying to do an auth on your health check. The idea we have for health checks is like, let's say if you're building an API and you're going to have a load balancer, and your load balancer is going to balance across several APIs, your load balancer's probably got a mechanism built in to be able to ping those different APIs to see when they're up. What endpoint are you going to point that to? Right? You need to make something up. If everybody is going to do that in the new world, which generally you are, if you're running on Kubernetes or any modern cloud platform, you probably have some of this stuff built in. So we should give you something to help you out with that. That's what this is. Right? And especially if you're in containers, port mapping's really easy. So we wanted to make it so that you could restrict it to a specific port really easy, which is why it's built this way and not built in some other way. It has a service and a system in here for you to do things like. So the idea here is you can add health checks, and then you might be able to go like add database check, right? And then the health check will only return healthy if your application can communicate with your database. That way you could do things like have Kubernetes rolling updates where your update will only deploy if you can talk to your Kubernetes will only send traffic to your app if it's capable of talking to the database, for example. Right? Seems nice. So we wanted to build that in. What else have we got? We want to be able to say app dot. We want some Swagger. Does everybody here know what Swagger is? Everybody nods. Fantastic. Does anybody here think that we shouldn't add Swagger to this thing, that it's not going to be useful? Yeah, Mark? I don't know, man. Okay, so use Swagger. So we're going to, in this case, we're going to use Swagger UI. He likes to put his hand up whenever anybody asks those sorts of obvious candy questions because, that's the way he is. ASP.NET Core. Has anybody used NSWAG before? A whole bunch of you other people have used Swashbuckle? That got most people saying yeah. Okay, good. I'm installing NSWAG. And then the code that you write here is you go app.use Swagger. Is my package manager console dead too? Look at that. Today is the best day to write code on this laptop, apparently. We're going to edit my CS proj. Right, now, boom. NSWAG.swashbuckle. I don't remember what version this is because I didn't check because I was going to use the built-in tooling for that. So, NuGet.org. Here's a fun tip for you all. If you press tab, you can search right here. Did anybody know that? Fantastic. I just taught you something. I'm pretty happy about that. What I don't know is if this is a problem with the internet in general, then this talk's going to go real bad. Right? Okay. So, while that thing's making up its mind, we're going to go whether or not it's going to, while it's making up its mind whether or not the internet's going to work, we're going to go here, and we're going to say .NuGet, and we're going to go packages, and we're going to go NSWAG, and we're going to say .ASP.NET Core. Oh, look, there's a version number. Fantastic. Oh, look at that. Look. All I did was copy it, and now magically it's in my CS proj file. How did that happen? I'm guessing this command line finished. Look at that. Fantastic. Okay. Now we need a using statement, and we're going to add Swagger with API. Well, we're going to add Swagger with API Explorer. Then we'll add this as like a. There was one there. I don't know if you guys saw it go past. It was like add Swagger UI3 with API Explorer. That'll probably merge these two commands. We're going to put them in because I figure some of you at least are probably going to want to go if app.isDeveloper, if env.isDevelopment around this thing. So we'll do that. Now we'll one last thing. Now that we've got Swagger in here, another thing that's kind of unfortunate about pressing F5 in an API project is you don't really want to actually execute your gets when you're running your app. So it seems unfortunate that you have to do that. So we're going to change this to Swagger now. All right. Most of all of this stuff that I'm doing here, by the way, I do intend to ship as a template so that we can just do file new and your template looks like this, and then you can go. Anybody who thinks that's a bad idea, you should come talk to me at the end because you might not have much time if you think it is. I expect to ship it as a as like a template on NuGet that you can download and choose optionally, and then eventually, based on what everybody thinks, work with everybody, and then eventually we'll make it the default and put it in the box, or not put it in the box as whatever the case may be. It looks like Visual Studio decided to download 3 copies of Windows whilst it was building my application, so you'll have to pardon how long this is taking. What we're going to do here is, now that we're going to run the application, it's going to open up Swagger UI. You'll see that there's Swagger UI. You guys have all seen that, so I'm going to hone in on a couple of very specific things. The first one, apparently it didn't even run at all after all of that. The first thing that we're going to do is look at the return code. So what are you guys expecting here when I look at the, you've seen values controller before, right? You receptor 200, it returns a string, yeah? We can try it out, we can execute it. I'm not going to do that, you guys have done that before. So there's nothing super new here that you couldn't do before. Health checks is kind of new. I've showed some people NSWAG. However, there's another thing that you can do, which is in 2.2 you can do something like this. You can add this assembly attribute to say API conventions type of default API conventions. Now this does a few interesting things, and what we're going to do here is I'm going to run my application now. For most of this stuff that I'm talking about, by the way, that's 2.1 and 2.2, if you go to John Galloway's talk later, he'll go a lot deeper. I'm skimming it, the stuff that's important for this kind of talk, to get into some more deeper stuff. But yeah, all that stuff will be available, or if you watch like the .NET Conf talks and things like that from last week, you'll see it. So if you open up this thing, the get values ID, get values are still the same, it just returns 200. But get values of ID, it says it returns a 200, it returns a 404, somehow it has this JSON object that it knows it's going to return, called a problem detail. Does anybody know what problem details are? No, not really. A couple of people are nodding, but not really. So problem details are an RFC for a standard way of returning an error condition from an API that can be kind of machine readable. So by implementing these conventions, by saying I want you to use these conventions, and you can write your own sets of these conventions, we've said we assume all your APIs could probably have an error, so they probably all return problem details, so there you go. We assume that if you've got a method called get that accepts an ID, you're probably going to return a 404, because what happens if the ID doesn't exist. You probably can return a problem detail, and you're probably going to return a success status code if it's there, right? So we're just going to give you all those attributes so that you don't need to add them to your type, right? Seems reasonable. And so that's why when you go look at that now, you see a bunch of extra data. Now, I'm not going to, because I had a little bit of extra time trying to get my machine working, there's an analyzer that you can add to your project as well, and it'll give you squigglies to say, oh, you're returning a status code here that your convention doesn't say that you're going to return, control dot here, and we'll add that attribute to your method for you. We don't want it to be like naggy though, so like it doesn't necessarily always say that. And as you saw here, I'm not actually returning a 404 from any of these things, even though it said I was returning a 404. So if the convention says that you're going to return a type, we'll tell you, we won't necessarily give you a thing saying, go do this, because it's not necessarily, in general, we believe it's okay to over document the types of status codes that you're going to return, so we kind of err on the side of that, at least for now. You guys can tell us what you think. I'm always interested to hear your opinion about this type of feature. This kind of experience of providing like conventions and analyzers in tooling so that Visual Studio helps you attribute your APIs the way you want is kind of a new area for us. So giving you some help for that. There's also some other things, right? So if you do things like, say like if model.isValid, if you say model.isValid in here, there's a check where, a really common piece of code you'll always say, it's like if model is valid, if like check model state, return bad request if the model is invalid, if you guys have all written that before. If you do that and you have these analyzers, it'll now go gray and you'll get squiggly saying, remove this code, ASP.NET has a filter that'll do this for you, so you don't need to. And then you can choose to turn the filter off if you don't want that behavior, or you just let it go and the analyzer tells you. There's no other real way for us to guide you down that path of where we've added a feature to remove this common pattern that everybody has to do, but how do we tell everybody? So now that we're shipping analyzers, we can do that sort of work. It's in our blog post, you should check it out. Okay, let's go back. So yeah, a template for helping you out would probably look something like this. Does that seem good? Yeah? Everybody's like, yeah, that sounds great. That's what I would probably, they're probably the first several things that I would do. So we talked about Swagger API conventions and analyzers. I didn't show this, but it'll be in some of the other stuff that I talked about, like Galloway's talk. One of the very first time I gave this demo was to the head of DevDiv, Julia. And I pressed F5. I said, okay, we've got an API, great. F5 and it 404'd because it didn't go to /API/values. And I went, that seems like a problem, don't you agree? It'd be nice if when you F5'd it in Visual Studio, it gave you something more useful than a browser to browse your API that you don't really use browsers for. So part of that is giving you a Swagger UI experience. Part of that is we're going to experiment with a command line tool to be able to once you've got Swagger, we'll give you like a directory tree. You'll be able to navigate around your application. You'll be able to execute gets. You'll be able to do a post and it'll open an editor with a pre-made post for you. A whole bunch of stuff like that. It'll be kind of an amalgamation of a bunch of other tools that you tend to go and install anyway as a developer, kind of mash them all together, hopefully give you something useful that you could use as a pretty good like kind of way to test and navigate around your app. Health checks we talked about. HTTP Client Factory we added because once you've built this API and you want something to talk to that API, then you also start talking about resiliency in cloud native applications. When you look at HTTP Client Factory, it manages a lot. How many of you keep HTTP Client Factory around forever? You just keep one. You new one up and you keep it around and you keep reusing it. It's okay. You put your hand up. Don't be shy. Good. How many of you new one up whenever you need one? You just new up HTTP client, use it, throw it away, dispose of it. Cool. Okay, great. All of you are in some way doing it wrong. So HTTP Client Factory will work around most of those problems for you. I can go into lots of details about it at the end if you want to go into it. It's not that big a deal, but it can be nice. But the bigger thing that HTTP Client Factory does, it effectively gives you outgoing middleware. So you have incoming middleware in ASP.NET Core. HTTP Client Factory gives you outgoing middleware, so you can look at HTTP requests that you're going to make and do stuff to them. So one of the things you could do is wrap them in a poly retry policy so that you can always automatically retry, right? Or you could build in a circuit breaker, or you could have the URI, have the thing that you give it go check do like manual DNS, right? You could request /HTTP/foo, or even just like foo, and then in the outgoing middleware, it can go like ask console what it is that you meant by that, and it'll get an IP address back, and then the actual request will be against your IP address. All that sort of stuff is possible with HTTP Client Factory. And then we're working on HTTP Client Factory has shipped, REPL has not yet. HTTP Client Factory is the only thing on this list that's kind of definitely shipped already. The rest of this stuff is already in preview. You can go get it. The last thing that isn't in preview yet, but we're doing is client gen. So once you've got your Swagger doc, we're going to provide some MS Build stuff so that you could add NSwag to your client project, and it'll generate a C# or a TypeScript client to be able to automate going and talking to that backend API. Right? Cool, but what about when I want to do something like this and I don't care about your HTTP? What about message queues? Background workers are cool. Web scale. If you want to do something like this, you can do something like this. It sounds great. Is anybody doing things like this now? You know, I've got my web app and it just puts a message on a queue and then it gets back to the user as quick as possible. Then you have several backend workers, right? Everyone's like, yeah, of course. I've tried to use the cloud, thanks. Okay, let's talk about that. I didn't need to do that because, anyway, let's go back here. Let's close this web application and let's go to this background queue worker console application. This is just a file new console app, ASP.NET Core console app, and it has this worker queue like open. That's all I've done. So let's delete this. So let's talk about what we want to do here. What we want to do is we want to say connect to, we're going to use Azure Storage Queues. We're going to pull message off of that queue that's open, that worker queue there. We're going to pretend like we do some work to it, and that's it. Seems simple enough, right? Cool. So we're going to connect to storage. We're going to like grab a message. We need to do the business to it, whatever that is, like whatever your business stuff is. We're going to like, we probably need to do something like handle bad messages. Like if you've got like a message that fails 5 times, then it's probably not going to work the 6th time. We probably need to do something about that. Probably be nice if it logged every now and then. Probably be nice if you could get the like what the queue name was from config, right? Cool. Now, if your ASP.NET Core application is the thing that's going to talk to this API, it'd be kind of nice. You've already sorted out config and logging and all that sort of stuff in your ASP.NET Core app, right? Kind of nice if you could do the same thing with your work with this web queue thing, right? But you can't, right? You can? Excellent. You can indeed. You're right. You can, because that was a trick question, of course, or a quick trick statement in this case. So, how many of you here know what? Oh man, package manager console again. Okay, how many of you know what generic host is? A few of you. Good. So you might know where this is going then. Okay, install package Microsoft.extensions.hosting. Right. So Microsoft Extensions hosting is where the generic host stuff lives. I'm also going to install Microsoft Extensions logging.console because we're going to do some console logging. I left out extensions. Thank you, everybody. You guys are great. I'll give you a green, no doubt. Oh, no. Oh. Man, okay. Microsoft Extensions logging. Console, and then I think I typed this 1,000 times this week without any Microsoft Extensions configuration environment variables. If I can't spell like extensions, what chance do I have of spelling environment variables, I ask you? Okay, so I installed Microsoft Extensions hosting. I installed the console logging. I installed environment variables config. So now I'm going to go var host junk var host equals new host builder. All right, and we're going to control our way to glory. I'm going to add the appropriate usings. We're going to say configure logging. This looks familiar, right? Does this look familiar to people? Yeah, there's a few nods. Yeah. If you've only used like ASP.NET Core, since we had like create default host builder, you might not have seen as much of this before, but trust me, it's happening at the beginning of your application. And then we're going to say like C goes to C.add environment variables. Boom, boom. All right. And then we control our way to glory here. We say bam. And now I don't think this one works for some reason, which I'll need to complain to somebody about. In that the control dot doesn't work to tell me to add this particular using, which is unfortunate. Okay, now that was a completely unnecessary build, but thank you. Okay, so I've added logging, I've added configuration. That was like 2 of the things over here. That's good. That's done, right? And then I need to actually we can build this, and then down here we can say host.run. And there's a host.run async, and if I wanted to go add the latest lang stuff, I could do that in here, but you know. And so then what I'm going to do here is this is what we call the generic host. We call it generic because it's more generic than web. It's basically the same pattern that you had for ASP.NET Core without anything specific to web in it. And what it does is where the web host is pre-configured to boot Kestrel and do web stuff, this is not. All it does is if you have any services called hosted services in your application, it'll run them. So what we're going to do is say add hosted service, and we're going to say queue worker, or something like that, right? Seems like a good enough name. And then we control our way to glory again. We say we need this method. And then this isn't a type yet, but we're going to make one. So let's go make ourselves a queue worker. It's going to be the thing that actually does the work, right? A queue worker. Makes sense. This is going to be the thing that does everything else. It's going to it's going to do the work, get the stuff from the queue and things like that. So we're going to implement iHosted service, right? So, yep, use that, and then control dot again, implement interface. So this is what the interface looks like. It's just start and stop with a cancellation token. So what the generic host gives us is it takes care of life cycle. Like I can control C this thing properly without having to try and handle control C and stuff like that in my console application. That's already done for you. With like a couple of lines of config, you could switch it over to listen to Windows service events. So this could become a Windows service, for example, or that's taken care of you. DI, config, logging is all built in now. It all works exactly the same way it does in ASP.NET Core. And this has a type called background service, which we're actually going to use instead of iHosted service. And it just gives us a task and a thread to be able to do stuff on. And it takes care of doing start and stop. And when the thing is closing down, it'll call stop. It'll give you a chance to gracefully shut down, and then you'll be done. Right? Cool. Now, bam, look at all that code. I'm amazing. So I have a code snippet which has all the code you need to talk to cloud storage, because like you've seen me typing, and man, that would have taken some time. So let's do this. We don't have Windows Azure Storage. I've shown you as many ways as possible of installing packages other than the actual .NET CLI, so let's continue down that path. And then that'll let us continue to control dot, which is the best way that I like to program, is just control dot until all of my problems are done. We don't have a config, but this is already saying go and grab this connection string from config here, which is one of the goals of our comments earlier, right, was to try and use config, because that seems like a good idea. I've heard occasionally you want to change things like connection strings. So let's make a constructor, iConfiguration, config. Let's like make this underscore config equals config. Once again, best way to program, control dot your way to glory. Oh no, I did the wrong control dot. Oh, I'm missing an I in this. Yeah, I am. Look at that. You guys are great. Could you guys like just, any chance you guys want to move to Redmond and just hang out behind me in my desk when I'm writing code during the day? I think that'd be pretty good. We'll call it extreme paired programming. So we're going to say iLogger, because we also wanted an iLogger. So this works the same way it does. We say call a queue worker, right? Logger. I can apparently spell logger. Logger. Let's control dot this first. You have to control dot in the right order, otherwise terrible things happen, right? Control dot. All right, thank you, Visual Studio productivity team. All right, now let's walk through real quick what this code does. It's not super interesting, like the point of this talk isn't to teach you how to use Azure Storage Queues, but I'm gonna give you like the brief rundown of what we're doing here. So we connect to our storage account. I have an environment variable with a connection string to a storage account already on my machine, which is why I had to go and download the environment variables config package. We're connecting to, we're creating a queue, a connection, effectively a client for a queue called worker queue here. That's what this is. And then we have this delay. This delay is how long does it sleep if there's no messages to process. Typically in here, you probably want to do some sort of exponential back-off kind of dealio, where like if you've got no messages overnight, you sleep for a really long time, and in the middle of the day when you've got lots of messages, you don't sleep at all, and you're just constantly checking, something like that, whatever is appropriate for your use cases. And then here we say, get me a message, and then if there is no message, we wait for that delay period we just talked about, because we're doing stuff pretty simply here. If we failed to process the message 3 times, this is all standard stuff for the thing, we're just going to delete it. You would probably put it into like a dead letter queue or a poison message queue or a blob storage or a, I don't know, send an email to the CEO, whatever you guys are going to do. Then we're just going to say we're processing it, and then we're going to delete it, and then we're done. And if there's any exceptions, it'll be unbelievable or impossible or something. So, bam. What do you think? Is this going to work? What? You don't know? Okay, good. Neither do I. So, worker queue, add message. Hello, NDC. Bam. Oh, look at that. Hello, NDC. $4 billion in computer science, let me do that. It's amazing. All right, so we just built a queue worker in the amount of time it's taken me to stand on stage. And you can now say, yeah, I did it, and it's extensible. We can change the logging system whenever we want, and the config system, and there's all these config providers we can choose, and it's got DI, and it's amazing. And you get to leverage the ecosystem of stuff that is ASP.NET Core and .NET Core, all of the extensions layer effectively, in your own little private application model, right? Because that's kind of what you've built here. However, it's not really an application model yet, because it's kind of hard-coded, right? A lot of this stuff that you're doing in here is kind of generic, right? Like all this like talking to a queue and stuff like that, that's kind of stuff that you've done. It's stuff that you're going to do. So if you're going to, I guess, if you are going to spin up 10 of these, 10 different ones, different domains, because you're building microservices, you're going to write this same code over and over again. And I know how much you guys like writing the same code over and over again, right? So what we're going to do is, and as all good developers, we're also trying to find, you know, a generic condiment dispenser when somebody asks us for the source. So we're going to say public class, let's call this queue handler, right? What if we could do this and we could say public void handle message, and we could say, what is this thing called? A cloud message or something or other? The type, what's the type of message? This thing. Cloud queue message. Nice. Cloud queue message, right? And then we're going to say, we're going to put an attribute on this thing. Let's control dot this. We're going to put an attribute on this, call it queue handler, and we're going to give it a string, and we're going to call it worker queue. All right? Now I'm going to control dot generate this in a new file. This is an attribute. And then I'm just going to control dot again to say, generate a constructor for me that accepts a queue, that accepts a string. So it looks like this. We're going to change this to queue name. I'm going to rename it with control dot. We'll leave that one as v because life is too short to change constructor parameter variables. Then I'm going to put a breakpoint right here, and I'm going to go back to my queue worker. So what I'm trying to do here, some of you may have already thought ahead, what if by adding your hosted service thing, this method got magically called for every message, and all of that other stuff that was common to everything we did, you could just handle that in a library, right? Yeah? And then you could be a framework team. Sounds great. Okay, so we're going to go here. We're going to go into a queue worker. We're going to go down to the bottom of the. We're going to go to the bottom of the method. That's the method. Yep. We're going to go here, and I'm going to type. Bam! I'm going to type faster than humanly possible, and then I'm going to control dot my way to glory, and then I'm going to explain a whole bunch of what this code does, and then we're going to implement our own. I apparently. You know what? Every time I've done this demo and dry run this demo, I made this same mistake. I forgot to make this public. So what we're going to do here is, let's do that, because otherwise it just like, making that public without doing that just kind of rubs me the wrong way. So what we've done here is I've defined a type called queue binding. It has the string, which is the name of the queue we're going to bind to. It has a method info, which is the method that's got the attribute on it. And it's got a queue, which is the queue, like the library, the queue client to be able to talk to the message queue. I have a list of them, and then I have this method called bind queue methods. It just loops through every type in the executing assembly, finds every method that has the attribute on it, and adds it to that list. Right? It's going to be super fast, trust me. So we're going to delete this code that creates a queue client. We're going to say bind, what do we say? Bind queue methods. We're going to give it the queue client, so that it knows how to create, it's going to use this queue client to create like the actual, you do queue client, create queue client, I guess. I don't know, names are weird. Names are weird to me, but I didn't help do them. Okay, so now in this while loop, we're just looping until the framework tells us to stop. We're going to say for each var binding in underscore queue bindings, we're going to then, at the end of this while loop, we're going to put in our close bracket. And then, instead of everywhere where we've got queue, we're going to say binding.queue, because we've got a queue there now, binding.queue. So this is very basic, like round robin-y type stuff. Like I think you would want something significantly more like complex than this if you were to actually build something, because like you'll find this will be really uneven in how it like distributes stuff across methods and weird things like that. But so now that's kind of there. And here, where before we were just saying process me some data, we're going to do a thing. We're going to call the method, right? We could just, effectively what we're doing here is we're going to say binding.method.invoke, right? .invoke. But you can't, we don't really want to do that because our new app programming model is going to take as much advantage of our extension stuff as it can. So instead we're going to add an iService provider. We're going to call it SP. We're going to make underscore SP equals SP here. So the service provider is how the DI stuff in ASP.NET Core functions. Then down here, we're going to say using var scope equals underscore SP dot create scope. Right? And then once again, the answer to all squigglies is control dot. And so we're going to create a scope. So if any of you have used scope services in any of the other ASP.NET Core, .NET Core stuff, what we're saying here is any scope services, you get a new instance of them for every message that comes in. That's what we're doing by creating a scope here. And so now what we're going to do is say activator utilities. We're going to say var handler equals activator utilities dot create instance. We're going to give it the scopes service provider. so that it only has so that it has the scope services and such. Then the type that we're gonna make is gonna be the binding, the method that we're gonna handle here. It's declaring type, right? And then that's it. That'll make. So now what this is gonna do is instantiate the class that method is in. So now I can do constructor injecting. I could inject an logger into its constructor, for example, and that will magically work, just like it does in any of your other any controller in ASP.NET Core, for example. Then I'm going to say binding.method.invoke. You're going to use the handler, and then we're going to give a new object array, and we're going to give it the message, so that the message gets passed in. Then we're going to build, and we're going to tap this to this podium for good luck, and we're going to press F5, and we're going to hope that it works, because life's also too short for unit tests. Then we're going to go in here, and we're going to add a new message, and we're going to say, yeah, like that. And we're going to say OK. And then I just hit a breakpoint in my method that has an attribute. We just built a dynamic framework for being able to, you can now give this queue, you could give these two classes, this attribute and this queue worker to somebody. They could add it to their project, they implement one of these methods, and bam, everything works. They don't even know anything about queues. It's amazing. You are the smartest person in the room, right? And my message has, yeah, see? Just so you have to get the full effect of the yeah, right? Yeah. That's right. Yes! That's what I was looking for. Okay, F5. All right. We just built a thing. And it's cool. You just built half of ASP.NET Core. It's amazing. There's lots more complexity if you actually try and build something like this in the real world. Whoa! I guess they changed the keyboard bindings on me. Okay, so we built that, and we built it in such a generic way that you not only get to leverage all of the extensions world, you also could share it with anybody you want, and they could leverage all of the extensions world. You could now there is also patterns for you to do things. So let's talk about what this is. What I just showed you was a pretty deep dive into hosted services. Don't feel in any way inferior if you didn't get all of that stuff that I just did. There was lots of stuff. The point of it was, there's a generic host. It has hosted services. It takes care of lifetime. So it takes care of Control-C and starting and stopping the console for me. It has lifetimes for Windows services. And being a Linux daemon, things like that, potentially, right? It has the builder pattern that you saw, which is the same as what you would see in an ASP.NET Core application. It then, by building a thing using that, by building a thing that uses that, touchscreens, you also get access to all of extensions. Now, extensions is deliberately designed. The reason it's called extensions and not ASP.NET Core is it's a significantly broader cross-cutting concern than just web. So you're going to want all of those things down the side there, probably in any application that you build, probably, right? You don't necessarily need DI, for example, but why not? It's great. And you can leave some of this stuff out, but in general, you're going to have DI, config, and logging, and lifetime as kind of the bare minimum, and then everything else you can choose to support or not. But you also will then opt into a bunch of patterns. If our queue worker needs to do config, it's well known how to do that. You use options, and you do it the same way MVC does it, and all of the stuff that ASP.NET Core has. Those questions have been answered for you. There is well-known ways of achieving that. Right? And then I hope and envision this cool set of big frameworks that build on top of all of that to provide all sorts of differentiating value. ASP.NET Core, conceptually, although not actually yet, is just an hosted service in generic host. And in the future, I hope that's the case, where there is generic host, and you go like add Kestrel hosted service, for example, and that's how you move into the Kestrel world. Already, you can add Orleans, which is the actor model thing. It is built on generic host. And for all of you who were sitting there going, hey, this thing that he's building looks a lot like WebJobs, it was exactly like WebJobs. And you know what else is built on this now? WebJobs. So if you take the WebJobs SDK, the newest preview of the WebJobs SDK, then you can do all this stuff. And you can do it now. There's an RC of the WebJobs SDK. For those of you who aren't aware, the WebJobs SDK is also what powers Azure Functions. Right? So the new version of that is built on that generic host. It's built the same way that we just built. We just built like a fifth of it. They should pay us, right? We just built that top one for them. It was easy, So they are now boasted on they are now built in. They have a hosted service, just like the hosted service we just had. It's a lot more complicated, a lot more advanced, a lot more configurable. It takes care of all the edge cases and conditions that I didn't take care of in my thing just now, and it's battle tested and such like that. And it'll let you do a bunch of this work, right? So what does that look like? Well, it looks almost like this. This is an ASP.NET Core web application. It's just doing values controller. Ignore this. See this that I'm deliberately drawing your attention to? Don't look at it, okay? Okay. So, I'll look in here in a minute. This is basically, you know how I said you could do extensions methods with configuration and stuff? Some of that stuff isn't quite there because the core WebJobs SDK, other than having a terrible name because it says Azure WebJobs SDK is its name, and you don't need to be either on Azure or be using WebJobs to be able to use it to do anything. It's not actually built just yet to do what I'm about to do, which is to mix it with ASP.NET Core. So in this application, you know that queue worker that we had? You could add it to an ASP.NET Core app, and then you would have a controller with HTTP and JSON, and a queue worker in the same process, sharing the same loggers, sharing the same business logic services that you've had. So what we're going to do here is, we're going to say add web jobs, use web jobs is the convention, use web jobs, and then we're going to say x.add Azure storage, bam! Now we've added web jobs. What this has done is exactly what all this is an extension method that in this method it says services.add hosted service, web jobs hosted service. You know what that does, we just built one, right? Then, the way that their model works is you make a new class, queue worker, right? And then I think I have one. I have web jobs. This goes till 6:40, right? Cool. Okay, good for answering. Okay, so this is what a web job looks like. So their programming model, their model is a little bit different from ours. It's okay. We were more inspired than they were. They put the queue trigger here inside the method, right? So this application now, if I was to run it, I could put a breakpoint here, and I have this stuff queue open, just like I had the other queue worker open before. And because I am binding just here, see that open the browser? Because this is an ASP.NET Core application. There is an API there. I can go ping it. I can do controller stuff. Oh, look at that, invalid JavaScript. Do you know what that was? Good job. Thank you, sir. I kind of asked for that. Okay, so what I think I'm seeing there is old messages in the queue. What I think I saw there was an old message in the queue that had an invalid JSON because about half an hour before I did this talk, I swear I completely forgot how to write JSON. And for like a good 3 tries, I created really, really stupid, like really stupid entries in this queue, and then just kept going, oh yeah, that's right. Oh yeah, that's right. Oh yeah, that's right. I don't know how to write JSON anymore. Okay, queue worker, bam. Now, the other thing that they do is they deserialize the type. So by putting a JSON string into my message, now magically it's a person object, because that is the magic of WebJobs SDK, right? So now you actually can use a supported library to do that thing that we did all that time that we spent building that thing, none of that was important. You don't need any of that. Okay, so we'll use the WebJobs SDK. So this, and the other thing, as you saw here, it's got an iLogger. Right, you're sharing services. These are the same. If I was to I could take application environment here, same application environment you'll get in your controller, right? Like it's all built in. So in this case, if you have any of you read the .NET Microservices Architecture Guidance with Cesar de la Torre's thing? Some of you are saying yes. One of the things he does there, which is another pattern that you see a bit, is you will have a kind of materialized view in a different service. You have microservice A owns all the data for A. But B kind of needs some of it, so it'll have like a copy in its own thing, and then have this message queue backplane. Whenever A changes some data, it'll put a message on the queue, and then B will update its thing if it seems appropriate. This is the kind. You might do something like that this way. You don't have to by any means, because a microservice doesn't have to mean the domain of a microservice doesn't have to be a single process. You could have anyway. Too much domain modeling. This talk is about technologies and frameworks. You could decide to have an API that takes care of all the data, and it listens to messages because some of its data is really a copy from someone else's domain, and it just updates it when the other thing tells it to. For example, if you want to do something like that. How was that? Yeah.
Could you run it as a Windows service?
Yeah. Because it's a generic host app. So if it's a generic host app, you could do that. You could do that stuff. I've not tried. Probably not. Mate, you should be able to. That was a really good question, though. Yeah. The point, like, because that web jobs programming model is really functions. So the question becomes, like, when do I want to use this instead of functions, right? And the answer to that is when you're not on functions, right? You still really want that programming model, but you're not necessarily on functions. If you've got a Kubernetes, the first person that everybody who falls in love with Kubernetes does is put everything on the Kubernetes cluster, right? Because it's magic. You might want some of those similar programming models elsewhere, right? Like in a Windows service, for example. I don't think many people have used the Windows service stuff in ASP in the extensions thing yet, but yeah, as far as it should work great, right? Like, yeah. Okay. Any questions about that demo? Any more? Bam. Future. So we talked about being able to do, we showed you HTTP JSON, we showed you Swagger, we showed you HTTP console stuff. In the far future, sometime before the heat death of the universe, there will be transport agnostic communication in what is today called ASP.NET Core, right? When I started this journey where I said, what does that microservices cloud native thing even mean? One of the things I did was go and just look at like every framework I could find that had said had been built specifically to solve the problems the developers face when building microservices. An overwhelmingly common theme is, well, I can do gRPC to my endpoint, or I can do HTTP to my endpoint, or I could do Thrift, right? It has, like, the transport that you're using to get to your business logic is independent of is able to be pluggable. And so you'll see the beginnings of this in SignalR. Have any of you used the new SignalR? Right, if you use new SignalR over TCP with Kestrel, there's no HTTP in there, right? And so that's just an ongoing effort where we're constantly refactoring the point to the world where Kestrel is a connection server. It can take care of doing connections. And then you can have a transport layer on top of that and some protocol layers to be able to have many different ways of getting to your load. So the first one of those that I think we'll probably start with is gRPC. You'll do a lot of binary stuff. And then can lead to other things. MQTT is like completely different. It's weird, it's strange, and it doesn't even, we may not ever get there. MQTT is so whenever we're going to try and build an abstraction or something, we try and build implementations for that ourselves. And we always try and build something ridiculous. At least one thing that's ridiculous to try and prove and push the thing as much as you can. MQTT is our example of that. Like if we can implement that, it's so different to everything else we do that it kind of means that we've probably done a pretty good job, right? So. Now, observability is probably one of the biggest problems that everybody faces when trying to do cloud native and microservices applications. Diagnostics, like it's so important. And one of the big gaps we have is observability, diagnostics. And basically, I'll be able to stand up every year and say that same thing and it will still be true. Because you can always give you better and more diagnostics. And the most value we can give you is a consistent way of getting and accessing all of those, and getting access to all of that for all of the ops, for all of your services. One of the big pains that Netflix had when they did much more polyglot stuff across all of the Netflix microservices was, well, all these different languages now have different kind of ways. We have to standardize for ops. Everybody needs to do like logging the same thing, and now the metrics to the same thing, right? We need to concentralize some stuff because we need to manage some of this, right, to some extent. And so in the future, I think that we're going to do a lot of work on metrics. I say I think here because none of this is committed in any way yet. This is what I think that I'm going to try and lead the team to do in the future. A big push for metrics, being able to get those to Prometheus, all those sorts of things. A big push for distributed tracing. There's already a bunch of distributed tracing stuff you can do. It's mostly tied to application insights, but a lot of the primitives are there. So make that better. One of the things that we have today that's kind of a problem is if you're doing distributed tracing, and A talks to B talks to C, and B isn't like enabled for a distributed tracing, you lose the context because it's not passing it along, right? There's a few of you who were like moved to speaking out loud at a talk because of that, which is great. That can be a problem. So like, try and make that easier. So we just always flow those things if we see them. Some people at Microsoft and Google have partnered up, and a bunch of others. The Google and Microsoft guys started it up, and then a bunch of other people joined, and they created a W3C community working group to form a paper, like a spec for what a distributed tracing context should look like. So we're going to do a bunch of work to try and like implement that and support that, and like we want to see things like open tracing exist and things like that, right? Cool. Bam. So in 2.2, we did a lot of work for some stuff called endpoints and endpoint routing. If you see any slides that say like, hey, routing got faster. It got faster kind of as a side effect of doing a bunch of work to move routing down. So some people that try and do microservices, I have, not super common, but fairly regularly, somebody log an issue, say, I don't want to use MVC, I don't care about V. Like, I hate V. Stop putting V in my program. Like, I don't want the V from MVC. There's no Vs in my application anywhere. Why am I writing that? That seems dumb. And then Fowler will invariably say, why don't we just rename it? Why don't we just add another thing that does exactly the same thing and call it something else? So then I'll stop logging messages. But what those people are trying to kind of saying is there's stuff from MVC you want in all of your applications, not necessarily all of it. And some of the biggest parts of that is routing. So today, routing only really happens at the use MVC part of your middleware pipeline. In the future, middleware will be able to know about routes and where routes are going to go. So for how many of you have done cores with your API today? The cross-origin request stuff, right? Did you do middleware and then realize you needed an attribute and then you went, oh, okay, and then you did it in 2 places? Yeah? There's a couple of guys nodding. Yeah? That'll go away with this because the middleware will be able to do everything because it'll know about the stuff from MVC. The reason you got to do it in 2 places is because MVC knows about MVC and routes and the middleware does not, right? This is kind of one possible future of where that could lead. If routing is core, like core in a very small layer on top of generic host, you can start doing stuff like this. There's no MVC in this. It's just mapping. It's just routing to code, right? You can do some stuff. You can do stuff. You can do syntax like this today, but not like built this way with this sort of performance characteristics. I expect this will have, but I've got no actual idea. This is complete vaporware. It was I copied and pasted it from an email from a design meeting. It's like summary, and then you could maybe even do something like this, where you say, map me a service. This is the type of my service. Require authorization. It's an API. Map get. And then MVC could then play in this world where sometimes you go to MVC. Maybe you go to Razor Pages. Maybe you go to this servicey thing up here. Right? That seems great. So that's a more future thinking thing as well. Probably, so for all of these, for these two, and for that routing stuff, probably like a 3.0 time frame if I get my way. And with that, I am Glenn Condren. I have been your host this evening. You've been a wonderful audience. Thank you very much. And I didn't think I would do it, but I finished 2 minutes early. So all of the questions that have been simmering in your brain for this whole time, you can ask them and I will answer to the best of my ability. And if there are none, or you would like to come up or see me later on around the conference, just come up and talk to me in person and I will talk to you. Don't be scared. Yeah.
The one you explained as a future thing, like the gRPC Prometheus
Yeah.
integration, and that the standard about the distributed already available in the
Absolutely. So I didn't make a point of this. You could build gRPC today, not built on any of that extension stuff that we've seen. If you go make a gRPC app, completely different to any like other .NET Core app you've built anywhere. You should have asked me while everybody was here, so I could have remembered to say that. But yeah, so we don't intend to replace that. I intend to provide an alternative, and in fact, we've already started talks with the guys who work on the .NET version of gRPC that work at Google, because what it is if you just want if you just want what gRPC's got, great, it should be there and you should be able to use it. Their thing uses their own native web server. We want ours to use Kestrel. We want it to be integrated with extensions. We want DI, we want configuration, we want logging, we want all that stuff. Theirs is not going to provide that. So if we want that, we have to do it. That's what I want from the gRPC workstream. Does that make sense? Sound good?
gRPC makes sense, but how about Prometheus and OpenTracing?
Yeah? What about them?
Why we cannot use it in the database for now?
You can use them in there's no metrics support in ASP.NET Core. We don't give you any metrics, so you can use Prometheus, but I don't know what you'll send there. You send your own metrics, I guess. How many times is the GC run? How many requests per second are you doing? How many exceptions have you had? What is the internals of system? What is the system doing? What is ASP.NET Core doing? That's what I mean by we will provide like internally a mechanism for metrics to flow. We will push stuff onto it, and we'll make you so you can put stuff on it, and we'll provide an easy mechanism to get it into Prometheus.
So it's not about logging Prometheus, it's about
Yeah. That's right. Yeah, that's right. Yeah, it'll all be built on all that tech, right? And I think a lot of the plumbing for that is actually already being built now. It just doesn't really have a way to get it out of proc right now. The lower levels are already working on it because it takes a lot of time for them to move. And there's a bunch of interesting problems, right? Like, if you want to take stats from the GC, you can't do it while the GC is running because the GC just kills everything. Like, what do you, right? So the GC has to like stash it somewhere that somewhere else can get it that the GC is not going to see. Like, I don't know. No.
So in this case, shall we spend on
So the today and tomorrow-ish is all stuff that's happening in kind of 2.1, 2.2 for the most part, which have times. The rest of it, no. It's probably 3.0, but I don't have anything more specific than anybody else. For most of the stuff we've talked about for 3.0 so far has been Windows Forms and stuff like that. This is stuff I hope to include in that wave, but I also have no commitment or plan for it, so we'll see.
So do you believe now is the right time to spend on logging some of these tools in our company we have planned for OpenTracing, for example?
I see. So that depends, right? Like that depends on when you need it. And I don't think that any of your work would be made useless by anything that we do. It should only be enhancing, because anything that you do in terms of Prometheus today is mostly going to be capturing your own metrics, and there's nothing we're going to do that's going to make that probably not much that there might be a slightly different or better way for you to be able to log them, but you're still going to have to do all the same work to kind of capture the metrics and stuff. So I wouldn't think so. Yeah, I think so. I guess the answer to that was like, yeah, it's probably a fine to keep investigating it. I don't think waiting for us will give you that much more value.
Your few projects your example projects that you would then
Yeah.
publish them, or slides or anything?
I can, yeah. I can publish the slides and the sample projects. I'll tweet them when I do. At CondrenG is my Twitter account. If any of you want them, because I didn't plan for that ahead of time, I didn't think anybody would want them.
Why not rename Swagger to OpenAPI now?
It's not my project. That's an open source library. It's not mine.
But the use Swagger part is yours, isn't it?
No. Yeah, that's all from the open source library. Yeah, from NSWAG. Yeah. We talked about building our own Swagger generation library, and like if there's a thing we want lots of people to use, but there's already an obvious and small number of really good projects out there that we can just tell people to use, and the guidance is pretty simple, then we won't build a competitor, which means in general, right? Which means that we will build stuff. So we built API. We wanted better Swagger generation. We could have built our own Swagger library. Instead, what we did was build a thing called API Explorer, and we did a lot of work. So those conventions that you saw, for example, they add metadata, they add data to the API Explorer, and we went and worked with all the Swagger author libraries to be able to get data from API Explorer so that their Swagger got better as a side effect of us doing work on this thing without us actually having to build our own like Swagger gen. And it's the same for client gen. When client gen becomes a thing, it'll be NSWAG that does client gen. It won't be us. right? And it'll be it'll probably be auto rest and then swag will be the two options. Does that make sense? Yeah, yeah.
So you'll be floating around this?
I'll be here. Any more questions that come to you, grab me at any time. I'm more than happy to talk to you about all sorts of nerdy and geeky things, especially if it involves Thundercats. Yeah?
I have a question about